Hello, good afternoon. Thank you for the opportunity and the incentive to look at an issue that has been troubling me for 30 years or so. You'll notice that the term that's applied to this is not system definitions, but system descriptions. I've been working with Lisp now for about 30 years, and over that time have worked on a lot of code. There's a site up at GitHub that has open source code that I've written over the years. And at the moment, my principal preoccupation is to work on a project with Datagraph that's called Dydra, which is a RDF store and Sparkle query processor. If anybody knows what those are. No? Yes? One. Okay. NoSQL, one of the branches of NoSQL, is based on RDF, which is the Resource Description Framework. Its view of the world is that you can decimate the world into triples, subject, predicate, object, store everything in terms of those, and then turn around and at the last minute construct your conclusions about the model you've built by running a query language called Sparkle over your repository and matching and projecting the results out into something that looks, in the end, very much like tables, but constructed on the fly without a schema. Your query is the schema. So I've been working on that for a couple years and have worked with build systems for a long time. Build and def system, I worked at the university. I used a Lisp machine for a project for one semester. That was it. But I've worked with all the others. And the question has always occurred to me, why do I have to say depends on? One of the things I hate about computer systems is when they turn around and say, you didn't tell me the right thing. Especially where if it's a build system, it knows whether it's going to build it right. Things fail. So why do I have to tell it? And why can't it figure that out? When I saw this conference and I thought, okay, well, this is a chance for me to look at this issue, and I wrote a proposal for a paper, I was castigated and remanded that I hadn't presented anything about the existing build systems. So Pittman's paper I knew, but I didn't know Robin's paper. I went back and looked at that. Those are the two people, Robbins and Ken Pittman, are the people who wrote the first descriptions of, well, what could a build system do? What does it have to do? What's it supposed to look at? What would you want to do with it? And one of the things that I found, now these are both people who were using Lisp at the time when, in the early days, when Lisp was pretty primitive. And two of the things that were in Robin's paper that were actually pretty interesting, he wanted to be able to have the system tell him how to patch things. If you changed one function, what did I have to change? I don't want to tell you. The system should tell me. The other thing that he wanted to be able to do was if one file changed, it should tell him what needed to be built, and he shouldn't have to do it. So he was at the point where he was writing build descriptions, but he knew he didn't want to do that. And the question is now, after 30 years, why are we still doing that? In particular, okay, one of the things that Ken Pittman thought was really bad was that so much attention was paid to the syntax of the build description. We're still doing that. Okay, so to jump to the conclusion, if you go to that page, you will see a list of everything that, well, there's one of them that I couldn't do. Everything that's in Quicklisp as a graph, which is the dependencies for the respective system as a graph at the level of function calling function, an analysis based on that of file level dependency, And then the part that didn't work, and this is a question of, well, what can you do and what can't you do? The part that didn't work was, in most cases, a projection of what the load or compile dependency would be. And I'll get to the question of why that didn't work out. Okay? That's 1,683 systems. 1684 didn't work because the complexity, the connections were too high, so the graph, I couldn't generate the graph. And the goal of this is to be able to do patching, to do more precise change analysis, to something which ASDF has recently sort of been able to do, transitivity of changes from one system to another, and to divorce the knowledge you have about how to build a system from a very primitive syntax for describing what's in there. Now, one of the perspectives on this that's important is Lisp. When you know the definition, what Lisp is as a abbreviation, right? There's this, that it's Lisp processing. What was the title of his paper? Okay. Lists were a secondary thing. It's about symbols. It's about symbol processing. Okay, so what if we take that and take that literally? Okay, how far can you get? This is supposed to be very hard to do. It's supposed to be impossible to do for lots of reasons. Ignore the system definitions. This is taking Quicklisp, which is several million lines of code. Ignore the system definitions. Don't try to be too smart. Don't emulate the compiler. Only do macro expansion if you have to. That is to say, if it is something that the runtime will macro expand. Macro expand it in order to get the structural changes, because that's the thing that a macro is going to kill you with. It's going to have the function calls in the wrong places. Emulate package definitions just in order to be able to get unambiguous symbols, right? We're talking about symbols. The one thing about a symbol that matters, it has to be unambiguous. You have to know it's this symbol, it's in this package, so that if anybody refers to it in another system, they call the function to refer to a symbol. You have to have the symbol, okay? And that was the hardest thing to do, because it turns out that these systems are not really meant to be read, which is a crime. People write their code so that you can't read it. You have to be compiling it in order to read it. Okay, but it's make-believe. I was fortunate in that SBCL exposes enough of their reader and their package processor that I could just tell it, if you can't figure it out, forget it. Skip the form, skip the file, whatever. Doing that was enough to read everything except things that claimed to be Lisp but were domain-specific languages. Read time evaluation. No, I can't do that. Reader macros. I'm not defining them. Just make believe that stuff doesn't exist and see how far you can get. Don't compile it. Don't build it. Don't execute anything. Now, in order then to work with this, you have to have some vocabulary for describing the relationships which one is going to recognize among the symbols. What are the things that matter? So I went looking. It turns out there is, that's 2, 4, 6, 8, 9. One of those provides, RDF. The important thing about RDF is that you can build ontologies that are a vocabulary, the relationships among the terms in the vocabulary that give you a language. There are 9 of those that talk about software. Most of them don't talk about the code. They talk about the process, they talk about the economics, they talk about the risk analysis. There's only one that actually talks about the code. There is one that goes further. It talks about individual statements in a Java program. And that's not going to be terribly useful either. But there was one that has the right thing, which turns into a fairly straightforward vocabulary for talking about the structure of programs, where the important things are source files, operators in a source file, and functions as a kind of operator, where the really important thing is that some operator is contained in a file, and some other operator is going to call another operator. How much can you say if that is all you know about your programs? The goals would be to be able to take source that you haven't seen. You have to identify the packages in order to be able to read it. You have to ideally construct the system based on the recognized requirements without the system without any description telling you what you're supposed to do. And you would like to be able to also do things like if there is a version change, you get a file checked out from Git. You analyze the two files. You see different function call structures or different things present. What do you have to build in order to accommodate the change that you've recognized? Again, to jump to a conclusion, this is Quicklisp in terms of the number of classes per system versus the number of functions per system. So that's how much of Quicklisp you can get with this naive analysis. Not doing anything special with the code, just looking for the symbols and the relationships among the symbols that you can see in the S expressions. This is a function call. This is a function definition. Class definitions too. Package definitions. Things that you can recognize just on the basis of the symbols in the common Lisp package, which are their standard operators. That's it. This is then, there is one sense in which there's something extra I must admit I did do. There's a question of authority. If someone has added an ASDF file, that implies to me that a particular person has authority over the code in that tree, everything under the ASDF file. That becomes a system, whatever that is. That means that by standard ASDF definitions, one tree might have 5 systems in it. Those things I reified as systems. These are the number of relationships between systems. Looking at system A had this symbol in a function call position. System B had the same symbol in the second position in an S expression after a defun. Just following that logic. And so there's a code walker that does this. It's a code walker that's 60 lines of code. It's a really stupid code walker. But it was enough to get this information out. That is to say, you start with that text, a little example that has 4 files in it, one system, okay? You throw away the system description. You extract what you can find in the S expressions in terms of the symbols that are referenced and the role that they have in the respective, with respect to an operator. And you get a whole bunch of files, a whole bunch of functions, relationships among the functions. You take the next step and say, okay, if something is defined in one file and referenced in another, then I know that you have a reference between those 2 files, and that's a dependency. Constructing, as a consequence of those inferred dependencies, the dependency relationship in that little baby system. If I were to have to build and load that, that's what I need to know. Where? If one is willing to find, to admit to certain conventions for what a test is, you even have the ability to say, if I were to change this function, what test do I have to run? So doing this with Quicklisp it had its 4 million lines of code. The crawl of its source took 2,000 seconds to extract all of this information from Quicklisp. Now, okay, so why did I feel as though I was able to do this now when I couldn't do it 30 years ago? The second thing on the list of code that I work on, Dydra, is this RDF store. You can take these decimated descriptions of the world, throw them in there, and then apply rules to the statements that you find in there to infer other relationships. I did two. One is, if you have certain relationships present in terms of referenced and defined functions and files within a system, you have file dependencies in that system. So in this one, you see a query which is looking for those particular relationships, and if it finds those, for these particular source objects, asserting a file requirement. Refers to, okay? Required by. The same thing for inter-system relationships. The systems, RDF gives you the ability to compartmentalize your storage in terms of things it calls graphs. I put each system in a graph so that it's possible to tell them apart. And then look for relationships like the file relationships within a system, looking for file relationships between graphs. And that told me, aha, this system depends on the other system. So we have another graph I've created, which are the system requirements, based on similar things, but between graphs. Just to give you an idea of, given that ontology that I showed you the bubble diagram with, these are the cardinality of the respective predicates, okay? So there are 227,000 cases where it said, aha, this function is defined in this file. Just as an example. To take this, how am I doing on time? I must have lots of time. Lots of time. Okay, good. To take an example that's not a little baby example, this is BKNR. This is just an arbitrary system pulled out of Quicklisp. These are the dependency relationships that are in that.
Can you filter water with this molecule?
No, I'm not that far. And then the question about being able to decide what should be loaded. This is another query that gets applied to the data that's in the BKNR graph, the data that describes the file dependencies. And this says, find all of the files that don't depend on anything. Look for the transitive relationships there between those files and any other ones. Spit them out to me in a certain order where one has to be careful that the path operation performs things in a breadth-first search, which I changed it to do. And it emits to you. This is I wouldn't guarantee it's correct. And there's a definite reason I can't guarantee it's correct. But that's a lot more than I knew when I just looked at the source code. Okay? This approach is very naive. It has lots of deficiencies. One particular deficiency is there are lots of cases where it looks at a form that's a macro that's defined in a system and says, oh, this has something that can't be in an operator position. Forget this. So ideally, if one wanted to do this on a production level, one would have to be able to do macro expansion, okay? Which means you'd have to do it either as a side effect of compilation, or which you don't want to do because you don't want to run the compiler to do this. But anyway, There happen to be two packages in Quicklisp that have the same name. And that does very bad things because it has you referring to the same symbol when you really shouldn't be. There are any number of files that do not have Lisp syntax in them, although they're called Lisp. Really things that are really far from templates, HTML template files that are called .lisp. Read eval, okay. Read time, compile time, side effects. I didn't pay attention at all to variables, but that's a non-issue as far as I'm concerned. In that it's just another kind of definition. It's just a no-value function in terms of the logic that gets applied to it. Circularity is a definite question, and I don't have a real answer for that one. Like this one right here. Which one goes first? That one would have to look at. But the most significant issue, the most significant impediment, because in order to resolve it, it will require that one do pre-compile time type propagation, is that methods are ambiguous. You do not know which method you're calling just based on its name. You can tell some things based on its signature, and in order to make any progress at all, I had to make believe I was doing some kind of type constraints on the functions by saying, okay, if I'm in a method and I'm calling another function, I might know which classes I'm using. So that other function is not going to be any one of the 20 methods. It's just going to be this one. And that got it to the point where I could get some kind of results. Before that, there was a case that every system was referring to every system. Okay? So just ignoring those three things, there are these three problems left over. An example of that is this, for example, right here. Any common function that has lots of methods is going to call this problem. Print object. Okay? If you define print object, is every system calling your print object? No. So you have to localize the classes that are known at the call site in order to decide which method you're calling. And that's the thing that makes the results interesting but not terribly realistic. So if you go to that site and you look at the graphs, they're all there for all the systems. They're interesting, but they're not completely accurate. At the same time, I've convinced myself that if ASDF ever breaks my build again, I'm going to build this and make it work. I don't want them. I really don't want them. They're like XCVB has these declarations at the top of the file. I do not want those. I would like to do it without those. In particular, because if I want to answer the question of, I just got a push from Git, what do I do? Or I recognize that I did diff on the file, and I recognize it's just this function changed. What do I do? That's what I want to be able to do, and I don't want annotations for that.
What I'm saying is just that suppose you now invoke your system in order to, in some respects, infer a system definition or an order, and you see that it breaks in one case.
Yeah, well,
one case cannot be handled by
I went in and I renamed the package. So it's fair game. Okay? Or if you were to bother to put declares in the functions for what the type is of the individual variable, then you can do everything. Okay? Yes. Yes. I didn't even read declares. Okay?
So, how about the kind of a refinement? Because the output of the process looks kind of like a proper load sequence of files, which may or may not work because of some parameters.
Yeah.
But then if you actually output a standard definition output and try to load the compiler, you might, if it's wrong, you
Yeah.
So could you then use those errors to refine the process again?
The store has your assertions as to what depends on what. You could change them. Or you could add annotations to the store saying, believe this one and not that one, and change your query. Now, this is what is better about this than ASDF. This has now divorced the model for the system and the logic for interpreting that model from the source code completely. And you can change one to do what you want.
How about some indirect forms of dependencies? Like, for instance, there's a method combination defined somewhere and generic functions using it somewhere else.
The code walker is dumb, but it's really particular. Okay? So that would mean that there would be a method in the code walker that says, def generic, look for the clause in there, which is its method combination, and be sensitive to relationships between those two things. The only relationships I do now are call. Refers to, okay? So there would be, you introduce other relationships in your model, and you'd extend your queries, or you would the query that ran to infer the dependency, you change the logic in that so it would be sensitive to other things in order to capture the dependency for you.
And so the corollary is it easy to hook other kinds of dependency detections?
It's all in the query.
Could you repeat the question, please?
Sorry. Hit the.
About the relationships other than call, about, for example, method combinators being declared in one place and using another place.
Yes. And the exercise that I performed was very restricted, but one could add to the ontology has in it only very few things. Come on, there it is. It has very few things. You would have to extend your vocabulary so that it had other relationships. You extend your ontology so it's capturing the things you would like to model. And you would extend the query so that it then interprets those things to draw the conclusions you want.
Have you tried comparing your results against what's written in Animal to see?
No, I'm not that far. As I know in many cases they're wrong because they get the method calls wrong. Okay?
So which ontologies did you use in your abstraction vocabulary? You have this list of 9.
Yeah, I'll show you.
Use parts that are relevant.
I used, this one covers everything, but it doesn't know the difference between a method and a macro. Okay? It's meant for Java, right? There's no methods. Well, there are methods in Java, but there are no macros in Java. Okay? So it didn't have so I added some things to it.
So you took the code one and modified it. Did you publish that?
No, the ontology is not, it's not code. Ontology is an RDF description or an OWL description. No, you're it. I started looking for this when I submitted the proposal for the paper, and it took me until about 3 weeks ago to find one. Okay?
It's a cool result.
It's very scary that you can't find standard descriptions for things.
Or just how poor something like Goku is.
Yeah.
Which everyone has got these already descriptions over everywhere, which say basically nothing.
Yeah.
I tried to write a system like this before unsuccessfully, and I found that there were two types of requirements. One is that I need to load this before this, and the other is I need to load this before I run this. And I found those were two separate things. Was I wrong?
Looking back through the descriptions of what people have of build description system, you have compile dependencies, you have load dependencies, and you have run dependencies. And you really need, in particular, the notion that you need to have defined macros before you can use them is a really important one. And I don't pay attention to that. So in order to make this really work, one would have to add more distinctions. My question was, can I even capture this information? Okay.
So your system is
Wait, I didn't hear you.
Your system assumes presence of all dependencies.
Well, in order to look at Quicklisp, yeah. But the diagram of BKNR, that was looking at just the things that are in that tree. So it's arbitrary. It walks a bunch of files. You give it the files, it walked them. So if you knew that you were only going to look at 5 different systems, you'd look at those 5 different systems. I wanted to take the extreme case. That's the ecosystem for Lisp code. Could it get anything out of that? Yeah.
Imagine a use case when you want to just create a new system and you write down all this old code you want to use, and then you want to infer, just use a Quicklisp as so you can query Quicklisp for system names here.
Yeah.
Apropos system apropos.
Yeah.
Would it work in this use case?
Well, that is a application level that would be on top of this. This doesn't do any searching for you. This is a repository that you apply queries to project data out of. That's as far as I got. This is not a running application. Okay.
Thank you very much.
Okay.